Okay, lads. Okay, guys. Now, what we gotta get into our head here is it's basically okay. Now, guys, it's basically a series. Okay, if I have T1 plus T2 plus T3 Tn. All of this added together is Sn. On the right hand side we have Sn formula, which is this here. So that's the Sn formula, and these parts here are all the T values. T1, T2, T3, Tn. Everybody on board with that part?
Yeah.
Okay, we're good. Now, what happens next is you go up and you prove for T1, okay, and or P1. Prove true for P1. Okay, so P1 is equal to 1 over T1, which is 1 over 3. What I'm trying to tell you is on the left hand side, when you're talking about P1, you're taking the first one. When you're talking about P2, you're actually adding the first two together. When you're talking about P3, it's the first three added together. Okay, everybody got that? Okay, now that's the left hand side is equal to 1/3. The right hand side is replace n with 1. 1 over 2 times 1 plus 1 equals 1 over 3. LHS equals RHS, true for P of 1. Everybody happy with that?
Yeah.
Now, so once you've done that, what's going to happen next is you're going to do assume true for P of K. Alright? So, assume true for P of K. Now, instead of Tn, what do you have this time?
TK.
TK. So it's 1 over TK minus 1 into TK plus 1. And then it's going to be 1 over 1 by 3 plus 1 over 3 by 5. And then I don't have to put the last one in, okay, if I don't want to. And then what about this side then? What does this change into?
K over 2K.
Which is the sum of the first K terms. K over 2K plus 1. Now that we're here, we now have to test P of K plus 1. Test P of K plus 1. Now, exactly the same thing. 1 over 1 by 3 plus 1 over 3 by 5 plus plus 1 over 2K minus 1. 2K plus 1. Now, we have to find out what is TK plus 1. Can anyone tell me what's the Tn formula? Tn formula is located here. Yeah? So just go replace n's with k plus 1. Now in both of these I have 2n, so we'll find out what 2n is. 2n equals 2 times k plus 1, which is 2k plus 2. Replace that with 2k plus 2, replace that one with 2k plus 2. So it's going to be 1 over, anybody?
2K plus 1.
2k plus 1, and then 2k plus 3.
Wait, sir.
Yeah.
I don't get why you have to put that on as well as the P of n.
Okay.
Why don't you just put it in that one? Why do you have to add that one on as well?
What had that one as well? It's like asking me what's the difference between S3 and S4. If it's S3, it's T1 plus T2 plus T3. And then if I say S4, which is one bigger than S3, you're basically asking me, why do I add on T4? That's what you're asking. So K plus 1 is 1 bigger than K. Therefore, I have to have an extra term at the end. Same thing. T3, this, if you will, this is your T3 here.
Yeah.
And then the extra one is T4.
Alright.
Okay, does that make sense?
Yeah.
Okay, now that that's cleared up, what we have is okay, so, and I'll just get rid of all this here. Sorry. Now guys, once we have that done, what can we say, what do we do next? we got to replace in the k plus 1 into the sk formula, or the sn formula. So where's that located? There. So it's going to be k plus 1, yeah, n with k. Then that's going to be 2k plus 2 again. 2k plus 2 plus 1. 2k plus 3. Now, looking at this, okay, what we're going to do next is we're going to take all of this here. Now, what do we replace this with? SK. Because look at it, it's exactly the same as this one here, and that equals that stuff there. So it's k over 2k plus 1. Now that you've done that, it's also plus 2k plus 1 all over 2k plus 3. Now guys, we're just going to prove that this in green here equals the right hand side. We're trying to prove that the LHS equals the blue RHS. Now, any suggestions on how you might do that? Do they have a common denominator right now?
No.
How will I give them a common denominator? Top and bottom by 2k plus 3 and 2k plus 3. Then what happens? I'm going to rub out the top part now. So anybody tell me what happens next? Huh? So, multiply it out, and when you multiply it out, what we're going to get is 2k squared plus 3k plus 1 all over 2k plus 3k plus 1. Factorize the top using the reference numbers. Everybody happy with me just to skip into the brackets? Huh?
2k plus 1. 2k plus 1.
Ah, yeah. 2k plus 1 and 2k plus 3. Okay, now that we've done that, you factorize the top and you're going to get 2k, what's it, 2k plus 1, k plus 1, all over 2k plus 1, 2k plus 3, and what cancels?
2k plus 1.
2k plus 1 cancels, and we have k plus 1 over 2k plus 3. Is that alright if I don't write down all the language?
Yeah.
It's always the same. Okay, I'll just say it out. Hence, P of k plus 1 is true, P of k is true, hence by the principle of mathematical induction, P of n is true. Right, now, can I move on?
Yeah.
Okay. Now, number 8.
Oh, fuck. This is great. God's sake.
That's based on Cardinals. Now, what we have here, guys, is this, okay? This here is a very fancy way of saying, T1 plus T2 plus all the way. Now, whichever letter is on top, see the Tn? That means it goes all the way to Tn. Okay? This means that to get T1, if I wanted to find out what T1 was, I replace it with the first dummy variable, which is 1. So T1 therefore equals 1 into 1 plus 3, which is 3. T1 is 3. If that read 0, I'd have to replace R with 0 to find what T1 is. Okay? Now,
4.
what?
T1's 4.
Oh, it is 4, you're right. Yeah, he's right. 1 multiplied by 1 plus 3 is 4. Now, guys, what else we're looking at here is we're also looking at this here. This box here represents what, can anybody tell me? The formula for Sn. Okay? So that's what we have there at the moment. Now, what we're going to do is we're going to prove for P1. So the proof for P1 is equal to T1. Do you agree with that? T1 is 1 into 1 plus 3. T1 equals 4. That equals the left hand side. the right hand side will equal 1 over 3 into 1 plus 1 into 1 plus 5. That also equals 12. LHS equals RHS, true for P1. Everybody happy with that?
4 and 12.
4 equals 4. Okay. Now guys, true for P1. Now, assume true for P of K means replace all n's you see with k's. Only n's. Okay? So, assume true for P of K, where P of K is going to be K, R equals 1, R into R plus 3, K over 3, K plus 1, K plus 5. Now, look at these. What does this mean? It means T1 added all the way up to TK.
Oh, so you just leave that as R's?
You can indeed, yes.
But is that
Only replace n's with k's. That's the whole point.
So it's wrong if you sub in K?
Yeah, I did that once. I was like, actually, no, that's not right. Okay. Now, prove for P of K plus 1. Now guys, look at P of K plus 1. We're going to have K plus 1 on top. You have R equals 1 here. You have R into R plus 3. Then you're going to have K plus 1 over 3. K plus 2 over and K plus 6. Everybody know where I got that from? Just replacing K's with K plus 1s. Now, can anybody tell me what is the difference between this one here and this one here?
K plus 1.
There's an extra term, and that extra term is called T of K plus 1. Okay? T of K plus 1. Now, once we've accepted that the extra term is T of K plus 1, well, I can then split this into, technically speaking, what I'm splitting it into is I'm technically splitting it into SK plus TK plus 1. That's what I'm splitting it into.
I don't understand why, if you want to find P1, sub in 1 for the R's, then if you want to find
Okay, P1 means the first term only, yeah? And this equation here is the general formula for any one you want. If I want to find T1, I replace R with 1. If I want to find T2, replace R with 2.
Yeah, but what if you want to find TK plus 1?
I replace R with K plus 1.
You just said you have to.
replace n's.
You don't replace it in here, beside the sigma sign. Okay? But for the TK plus 1, so lads, T1 is me replacing R with 1.
Yeah.
Tn would be me replacing R with n.
Yeah.
And then me doing T of K plus 1. What I'm saying is, for your two induction parts, it always stays as R. And then when you're finding out what TK is, then you can change it. Okay? So T of K plus 1 is K plus 1 into K plus 4. I replaced n with K plus 1. Now, what did we say SK was again? Can you tell me what I said SK was?
K over 3, K plus 1.
There it is there. K over 3.
K plus 1.
K plus 1, K plus 5. Now, what about the other one? What did I say T of K plus 1 was? K plus 1, K plus 4. And that all equals what's in the red. K plus 1 over 3. And now that can be a big line with the 3 underneath. Because the 3 is divided into the result of multiplying all of them together. Now that we're here, okay, can anyone tell me what should I do over here? I should give it a 3 on the bottom and 3 on the top. Okay? Once I've done that, what can I factorise out of that? Just the left hand side now. We're just zoning in on the left hand side. and over 3, right? So k plus 1 over 3 means I've created this part here already. It's just a matter of matching up what's left to k plus 2, k plus 6. So let's see if I'm able to do that. Okay, so what we have is going to be, we're going to have k multiplied by k plus 5.
K squared plus 5k.
K squared plus 5k. Then we're going to have 3 times k plus 4.
3k plus 12.
And 3k plus 12. Now guys, I'm just going to rub this out. I'm sorry, we're running out of space here, so I'm just going to change that into 8k plus 12. Is that alright?
Do you not have to, do you know 2k plus 1s left over then?
Yeah.
Let me show you that in a second. What I say was 8k plus 12?
Yeah.
Now, you asked me did I have 2k plus 1s left over, is what you were asking me, right? When I factorised this, for instance, Connor, back in junior cert, right, you would have had something like this.
No, 3x, right?
And 3xz minus 2xy. Look at the 2x's, yeah? If I remove them outside the bracket, the 2x's turn into 1x. That's why I did it to k plus 1s. When I took them out of the bracket, they removed to the outside as 1.
Well, I was saying more because the k plus 1 on the right side of the equation.
Oh yeah, I'm ignoring the right hand side completely.
I'm talking about like on the right hand side of the equation, on the left hand side. The k plus 1 get there, it's being multiplied by 3, so do you not have 2 more?
No, because I removed it out to the outside. There it is there. This x is getting multiplied by 2. Yet when I factorise that out, I can multiply 2 by the end one. See the way I took out the x? The 2x's got removed to the outside of the bracket.
Yeah.
And what you're arguing is the k plus 1 not getting multiplied by the 2, or is the x not getting multiplied by the 2? Well, it's not anymore because I put it to the outside.
But it still can be.
So if you multiplied all that out, you get the exact same thing you just factorised.
Yeah.
Alright, okay.
Okay? And then when I factorise that, it's going to go into k plus 2, k plus 6 when you do the reference number. So just do the reference number there. And
Are you basically essentially like cancelling k plus 1 over 3 on both sides?
No, haven't cancelled anything yet. I don't have to. I've just after turning the left hand side. I completely ignored the right hand side. I did nothing with it. I just changed everything on this side of the line into that there, and now they're both identical to each other. And that means that it's true for P of k. True for P of k plus 1. If P of k is true, hence by the principle of mathematical induction, P of n is true. Okay. Alright guys. Any questions on that? No, we're just going to continue. Yeah, you can go. Okay guys, so look, here we have here. Tn. The formula for any term I want is that there. It's an arithmetic series. How do I know that? Plus d every time. D, 2d, a plus 3d, a plus 4d. This here is what guys? Sn. Can I skip and just go into P of k?
Yeah.
Okay. P of k, therefore, is a plus d plus dot 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 plus a plus k minus 1 times d. You happy with that?
Yeah.
Replace n's with k's. K over 2 into 2a plus k minus 1 times d. Close. P of k plus 1. Now, P of k plus 1 is going to be one term longer. A plus d plus dot 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 a plus k minus 1 times d. That's still tk. And then it finally has that extra term we're talking about, which is t of k plus 1. And what is t of k plus 1? A plus, replace k with k plus 1. So it just comes kd. And then on the other side it's going to be k plus 1 all over 2 into 2a. And that's going to be k plus 1 minus 1. kd. close it up. Put that in brackets as well, just to lock it in there. Okay. Now that you've done that, can anybody tell me my next move?
Put the Q on the bottom of your
Not just yet. What is? Wait a second. What is here to here? SK. What is SK? This here. So it's going to be K over 2 into 2A plus K minus 1 times D. Now guys, plus A plus KD. Now, here's your problem. You're trying to prove that the left side equals the right hand side. So at this point in time, I'm now in a position where I just completely ignore that part. It's complete, it's done. I'm now going to manipulate the left hand side. What would be a good start off to manipulating the left hand side? Fraction. Okay, now you've done that. It's all going to be over 2. Now, lads, keep quiet please. Now, what I need to do is, I'm going to have to multiply in everything here, so it's going to be slightly messy. What I do to save myself time in the test is I say, look, that's KD minus D. Is everybody happy with that? Yeah. Now, I now got to multiply everything by K. So I'm going to get 2AK plus K squared D minus DK.
1DK.
Okay, and 2A plus 2KD. And I have to turn it into this. That's the hard part. Okay, I'm going to turn it into that somehow. Now, what I'm going to do here is see what is the same. DK and KD are roughly the same thing, aren't they? Yeah. So, therefore, what it's going to turn into is it's going to be 2 on the bottom, and it's going to be 2AK plus K squared D. We'll call it plus KD plus 2A. Now, guys, if you guys went back to your junior cert factorising chapter 2, you would see this question in the top part in that. Now, what I know is that I have to turn this right hand side. This part here has to turn up into the part that's directly above it in red. You have to turn into each other, okay? So, what I'm taking is factorising. I'm going to have to do a lot of factorising here. Now, to factorise this, what you're going to do okay, so what we're going to have to do here, guys, is we're going to have to factorise it. Now, when I'm factorising something, and if I was to give you a junior cert question, guys, like this, if I gave you a really simple one, like 3x minus 6 minus 6z, okay, and then I was to give you minus, let me see, 6ax plus 3az. If I gave you that in the junior cert, and I said, guys, factorise that. Now, what I see is this. Okay, I'm pretty good at this stuff, so this is what I see. I see 3, 6, 6, 3. I want 3, 6, 3, 6. So what I'd rearrange that to is I'd go, that's 3x minus 6z, and then I'd say that's 3az minus 6ax, and then I'd factorise 3 into x minus 2z, and then this one would be 3a into x minus
2x minus z.
Oh, which one is it?
2x minus z.
2x minus z.
Oh, that's a z.
No,
you just written down the next to it could be a z.
Oh, sorry guys, that's meant to be an x, and that's meant to be a z. Sorry guys.
Well, no.
No, I was meant to change the question, sorry. I just like, Sorry guys, give me 1 second with it.
Watch.
Okay guys, just give me 1 second with this question. Yeah, sorry, the x is meant to be the smaller value. Sorry guys, that's an x and that's a z. Now, what I was trying to explain to you still holds. You gotta do 3, 6, 3, 6. So I say 3x minus 6z plus 3ax minus 6az. And then what I do is I take out 3 into x minus 2z, and that would be 3a into x minus 2z. And because both brackets are the same, what's the end to this?
3a plus 3a.
Into x minus 2z. Now, the reason why I did that question is we're going to do something similar here, where I'm looking down at this and I'm going, okay, what we have here is all over 2. And what I have here is 2 followed by k, and these 2 are the wrong way around. I'd like the 2 to lead the other one. So I'm going to get 2ak plus k squared d into 2a. Now, there's a problem with 2a and kd. There's nothing I can take out of them, is there not?
No.
There isn't, but it might work out anyway.
It's fine, that's what you want.
It'll work out anyway to my knowledge. Now look at this. What can we take out of the first 2? K into 2a plus kd.
Yeah.
Look, the same thing is there.
Yeah.
And then we can't take anything out of the second one.
So it's plus 1.
Plus 1 into 2a plus kd. Put them together and you're going to get k plus 1 into 2a plus kd all over 2. That's how you do it there. There's a difficult question at the end. Okay, you will have to go over it again. Okay. Okay lads, last one. Okay guys, so look at this. Okay, once again, this is one of these ones that has the sigma sign in it. I'm going to skip p of 1 once again. Is p of 1 okay to skip?
Yeah.
Okay, I'm going to go straight for assume true for p of k. Now, like last time, p equals p of k. This whole thing is p of n. If I want to convert p of n into p of k, it's exactly what your eyesight tells you. It's replacing all n's you see with k's. So, I'm going to get the sum of k r equals 1, r plus 1 to the power of 2r, all over k into 2k plus 1. Stop there. I'm next going to try and prove for p of k plus 1. Now, p of k plus 1, once again, it obeys exactly the same rules. We're going to have k plus 1 instead of k. R is still there. R plus 1, 2 to the R, unaffected. Other side is affected. K plus 1. Add in another plus 1 there, and what do we get? 2k plus 2. Stop here. Now guys, we next have to do a direct comparison of what is the difference between this one and this one. Can anybody tell me the difference between the two of them?
One
of them represents sk, the other one has k plus 1 terms. What's the difference between sk and s of k plus 1?
T to the k plus 1.
One extra term, and the extra term is the last term, t of k plus 1. So, I'm going to replace this. This is getting s of k plus 1 is getting replaced with s of k plus tk plus 1. In the same way, S5 would equal S4 plus T5. Okay, that's what we're doing. So, what we're doing here is we're saying that SK equals this part here. So it's going to be K into 2K plus 1. That's going to be added on to. Now we have to find out what TK is. T of K plus 1 is the general formula. Any R I see, I replace it with K plus 1. Only now, for T of K plus 1 do you do it. So T of K plus 1 will equal K plus 2 because that's basically going to be k plus 1 plus 1, 2 to the power of k plus 1. Now lads, on the other side, do you see the way they're not speaking the same power language? K plus 2 is not the same thing as K plus 1. I need a translator. So to translate that, what we're going to get is 2 to the power of 1. Is that the same thing?
Yeah.
When you add them together?
Yeah.
K plus 2. So, what I'm going to get is, it's going to be 2 multiplied by K plus 1 multiplied by 2K plus 1. You see the way I just moved the 2 to the front? If I multiply the two of these by each other again, it will turn back into K plus 2. No worries about that. So, what we have next, guys, is going to be, I got to turn what's on the right side into what's on the left side into what's on the right side. So, I'm going to get K squared plus 2K. There has to be an extra 2 somewhere.
You don't factorize out 2 to the k plus 1.
Right. Now, what's going to happen next is I'm going to multiply this out. Now, what's going to happen is we're going to get K into 2K plus 1. Multiply K by 2K plus 1. That's going to be another K, 2K plus 1. Multiply 2 by that, and we're going to get 2 into 2k plus 1. Now, when you combine the two of these together, it's like x plus x, isn't it? They're the same thing. So now there's 2 of them when you add them together. It's like xy plus xy. xy plus xy is 2xy. So in effect, what's going to happen is, I'm just going to rub out the first one. I'm just going to put a 2 in front of it. Okay, now that I've put this 2 in front of it, what's going to happen next is I'm going to factorize 2 out of both of them. And then I'm going to be left with 2. And I'm going to factorize out the 2k plus 1 as well. And what I'm going to be left with is just going to be left with k and plus 1. And they're exactly the same thing. In the same way, 3 multiplied by 5 multiplied by 4 is the same thing as 5 multiplied by 3 multiplied by 4. If the multiplication's in a different order, it doesn't matter. They're all being multiplied by each other. Okay. Okay guys. What questions do I do there today?